Graph theory and rectangular crossing number. Hello guys, my name is Jeremi Aruperes. Right now we're gonna give a little explanation about what is graph theory and rectangular crossing number. But right now I'm feeling tired and I'm so sleepy right now, so I'm asking my friend to explain it for you.
Hi guys, I'm Jeremy's friend, and my name is Professor Einstein Da Vinci Newton Tesla Pythagoras Alexander Caesar DiCaprio. Or you can call me Mad Scientist. I'm gonna explain to you about graph theory and rectangular crossing number. Before that, let's move to a better place.
Okay Mad Scientist, now explain about the graph theory.
Let's start with a brief of history about graph. The paper written by Leonhard Euler on the 7 bridges of Königsberg and published in 1736 is regarded as the first paper in the history of graph theory. This paper, as well as the one written by Vandermonde on the night problem, carried on with the analysis situs initiated by Leibniz. Euler's formula relating the number of edges, vertices, and faces of a convex polyhedron was studied and generalized by Cauchy and Alcubierre, and represents the beginning of the branch of mathematics known as topology. In mathematics, graph theory is the study of graph, which are mathematical structures used to model pairwise relations between objects. Graph can also be defined as mathematical representation of a network, and it describes the relationship between edges and nodes. There are two types of graph. The first is undirected graph. An undirected graph is a set of objects called vertices or nodes that are connected together, where all the edges are bidirectional. An undirected graph is sometimes called a directed network. The second is directed graph. A directed graph is a set of objects that are connected together, where all the edges are directed from one vertex to another. A directed graph is sometimes called a graph or a directed network.
Okay, can I go home now?
Wait, I haven't explained about rectangular crossing number yet.
Oh yeah, I forgot.
Now I'm going to explain about rectangular crossing number. Determining the crossing number continues to be of great importance in graph drawing, as user studies have shown that drawing graphs with few crossings makes it easier for people to understand drawing. The crossing number inequality states that, for graphs where the number of edges is sufficiently larger than the number n of vertices, the crossing number is at least proportional to E circumflex n/n circumflex 2. It has applications in velocity design and incidence geometry.
Wow. Are you done? Cause I want to sleep.
Without further qualification, the crossing number allows drawings in which the edges may be represented by arbitrary curves. A variation of this concept, rectilinear crossing number, requires all edges to be straight line segments, and may differ from crossing number. In particular, the rectilinear crossing number of a complete graph is essentially the same as the minimum number of convex quadrilaterals determined by a set of endpoints in general position. For the purposes of defining the crossing number, a drawing of an undirected graph is a mapping from the vertices of the graph to disjoint points in the plane, and from the edges of the graph to curves connecting their two endpoints. No vertex should be mapped onto an edge that it is not an endpoint of, and whenever two edges of curves that intersect, other than at a shared endpoint, their intersections should form a finite set of proper crossings, where the two curves are transverse. A crossing is counted separately for each of these crossing points, for each pair of edges that cross. The crossing number of a graph is then the minimum, over all such drawings, of the number of crossings in a drawing. That's it.
Finally, I can go to sleep.
Before you go to sleep, we should make the ending of the video.
Not interested. Do it yourself.
Alright, you lazy kid. Okay guys, thank you for watching this video, and don't forget to like, comment and subscribe.